Hi guys, Mrs. H here. Today we're going to be looking at chemical equations and chemical reactions. So at the end of this, you're going to be able to look at and understand the words and the chemical formulas used to express a chemical reaction and also how to balance these chemical reactions. And again, notice we have some vocabulary here as well. So, describing a chemical reaction. So, chemical reactions occur when we get a new substance form. So, I'm going to take hydrogen and I'm going to take oxygen and I'm going to chemically have a reaction. So, we're going to change the physical properties of the substance and I'm going to get something new. I'm going to get a compound like water. So, whatever I started with, we call the reactants. Those are our ingredients. And whatever I end up with, that's what we call our products. Another way I like to think of this is think of baking a cake, right? Baking a cake is a chemical reaction. I start with flour and sugar and all our list of ingredients up at the top of the directions. And I mix them all together and then I put them in the oven and I bake, right? I make a cake. So my ingredients are my reactants, and the final product, my cake, is, again, notice the word I said, product, right? So that's the words that we use to describe chemical reactions. We use the words reactants and products, what you start with, what you end with. And remember, what you started with and what you end with will have different physical properties. And the reason why they will have different physical properties is because it's new material. I'm taking my oxygen that I breathe in and taking the hydrogen and I'm going to get, again, here's my water, right? And it's a new chemical makeup and it's going to have new chemical and physical properties. So in order to save time, and it's easier to do it this way, we write this in a chemical formula, and it's just a summary or a description of what's happening on a molecular level. So again, when we write this on the on the left side is your reactants, and then we use this arrow, and that's yields, and then the right side is the products. So anything you start with, go on the left side of the equation. Then you do a yield sign, and that means I'm going to make, I'm going to change into, I'm going to produce, I'm going to end up with. And what do we end up with? That's the reactants, and that goes on the right side of the chemical equation. And again, this is just a quick shorthand expression of what's happening to the atoms and how they're rearranging themselves. And so sometimes we have more than one reactant, and actually sometimes we have more than one product. So how do we differentiate that? Well, we use this plus sign. Just like in math, you're adding to. So I'm going to add reactant 1 to add reactant 2. I'm going to add my oxygen. I'm going to add my hydrogen. And we're going to add them together, or they're going to, hydrogen and oxygen are going to react with each other, right? And so what does it yield? What does it produce? That water. And again, on the product side, we use the word and. So the plus side can be and as well. So we say reacts with or and, so that we can understand verbally how we say the chemical equation with the expression of the chemical reaction or a chemical equation. So here I have multiple reactants and multiple products. So how would we say this? I would say reactant 1 and reactant 2 yields product 1 and product 2. I could also say reactant 1 reacts with reactant 2 and makes product 1 and product 2. Again, notice it's just a little difference in wording, but it still means the same thing, but just a little difference, a little variation. So word equations, when we actually write the name out, we don't really use it very often because, again, we're doing the chemical equation because we want to save ink and we want to save time. But sometimes we do use the full names. And so here would be an example. Magnesium reacts with oxygen to produce magnesium oxide. I could say magnesium and oxygen react together to make magnesium oxide. Again, my words, just a few little changes, but the meaning didn't change. Just like calling me Mrs. H and calling me Mrs. Helbing is still the same thing, just a little variation, same meaning. Okay, so let's do a quick review. See if you can answer these 3 questions. Okay, was it kind of hard? Could you think of it in your head how it would look? Well, let's try them out. So here I have hydrogen reacts with oxygen to form water. So how would this look in the full name written out? I would say hydrogen with the plus sign, oxygen, and then the arrow with water. And so again, how would I say this? Hydrogen and oxygen react to form water. Notice again, my reactants are on my left side and my products are on my right side. Notice we use the little arrow to mean yields or reacts with, and then the plus sign meaning adding or what we're putting together. So let's try another one. So I have sodium reacts with hydrochloric acid to form sodium chloride and hydrogen. So sodium plus hydrochloric acid. Notice the arrow to represent yields. Yields or produces sodium chloride plus hydrogen. Again, notice the reactants are on the left side and the products are on the right side. Also notice we're separating the reactants and products is the little arrow, and then the plus signs to separate the 2 products from the 2 reactants. And then our last one, copper oxide reacts with carbon to form copper and carbon dioxide. Notice I have copper oxide plus carbon yields copper plus carbon dioxide. So again, notice my reactants are on my left side, my products are on the right side. Notice they're separated by the yield sign, the arrow, and then separating the 2 reactants is a plus sign, and separating my 2 products is also a plus sign. Writing the words is not necessarily the most efficient. And again, the idea is writing out chemical equations is a shorthand. It's quick. It's an annotation. So we would use the chemical formulas in place of these words. So if you notice, these were some of the reactions that we did before. We said water, hydrochloric acid, carbon dioxide, sodium chloride, sodium hydroxide. So instead of writing out the full name, we can actually replace the full name with the chemical formula. And so this is actually the easiest shorthand way to summarize the chemical reaction that's occurring. So let's go ahead and look at that with the chemical reactions. So again, here are the 2 reactions. Hydrochloric acid and sodium hydroxide gives or produces sodium chloride and water. And then coal, which is carbon, reacts with oxygen gas to produce to produce carbon dioxide. So what would those 2 reactions look like if I would do it in shorthand? So hydrochloric acid, that's HCl, and sodium hydroxide is NaOH. So notice the and we've replaced with the plus sign, and gives, remember gives means produce, so I need to have a yield. So then sodium chloride is NaCl, and with our plus sign, water, H2O. So HCl plus NaOH yields NaCl plus H2O. So that's how you would write that out. And that's what it means. Hydrochloric acid and sodium hydroxide produces salt and water. Okay, that's the chemical reaction that we just did. Notice, a lot simpler to write. Shorthand, there's a lot of writing going on here. So this is just the chemist's shorthand. They're lazy. They don't want to write it all out. So they write it in shorthand. So let's look at the other one. So we have carbon, C, plus oxygen, which is O2, produces, so we need our yield sign, carbon dioxide. So that would be CO2. So C plus O2 yields CO2. Much easier, right? Look at how long that sentence was. Look at how short this sentence is. Much easier to write. So now we're not finished with just writing the chemical equation because of the law of conservation of mass. So the law of conservation of mass basically says, not basically, it does, there's no basic about it. It states that matter can't be created or destroyed. As much as magicians like to pretend like they can pull a rabbit out of a magic hat and it appears out of nowhere, that's not true. They're tricking your brain, right? They're illusionists. It's a trick. That rabbit wasn't created. It came from somewhere. So atoms can't be created or destroyed. So they have to come from somewhere. This is called the law of conservation of mass. That's what we call it. So when we write our chemical equations, we need to make sure that we're showing that we are not destroying matter and we're not creating matter. And so what we do is we balance equations to show that. And so let's go ahead and look at that. So there's been some theories to prove this. So if you weighed all the ingredients that you had before you baked your cake and then bake your cake, rebake your, I can't speak. If you weigh all of your mass from your ingredients and then weigh your product, the cake, they're going to weigh the exact same. Now you have to also remember some things are gases and become a gas, but you'd have to weigh that as well. And they wouldn't weigh the exact same. Now, when you get into chemistry class, you will experience that. You will do chemical reactions where you actually demonstrate the law of conservation of mass, that what you started with is what you end with. So how do we do that? So in order to do this, we need to put coefficients. So the coefficient, remember, tells us the number of molecules we have of that substance. So by putting a coefficient in front of our compounds or in front of our molecules, we can represent how many of those we need. So like it's saying, I need 2 bags of cheese, right? I need 2 cups of water. The cups tells you how much water you need. The coefficient tells you how much you need. How many molecules do you need in order for this to happen? Because as we all know, if you don't add enough sugar to your Kool-Aid, it tastes terrible and it's not Kool-Aid. You all know if you screw up your measurements in baking a cake, the cake is going to taste terrible, right? So how much the quantity matters. Your coefficient in front of your molecules tells you how much. So let's look at this. Notice this diagram. I have 1C, here's your carbon with 1, 2, 3, 4. So this is a model to represent methane. So here's our molecule, CH4. Notice that I need 2 oxygens, 2 oxygens that are 2 oxygens together, and it's going to make 1 CO2, which has 1 carbon and 2 oxygens and 2 water molecules. 1 molecule with an excuse me, an oxygen and oxygen and hydrogens here, and an oxygen and hydrogen here. So let's look at this. The carbon is C, and that's that black dot. Notice there's 1 black molecule on each side. Notice there's 1, 2, 3, 4 white molecules, 4 hydrogens, and 1, 2, 3, 4 hydrogens on both sides of the equation. So then lastly, notice there's 1, 2, 3, 4 O's or 4 oxygens on the reactant side. So I have 1, 2, 3, 4 oxygens on the product side. So in order for me to have 1 methane plus 2 oxygen will produce 1 carbon dioxide and 2 water molecules. That's the only way this molecule will work. If I don't have enough oxygens, I'm not going to be able to make my water molecules. If I don't have enough hydrogen, where's the, so it has to be balanced. Where are these hydrogens going to go if there's not enough oxygens, right? They'll have no place to go. So we need to make sure we have enough oxygen over here. so that my hydrogens, when there's the chemical reaction, has a place to go. Otherwise, you won't be making carbon dioxide and water. You would have something different that you would be making. So the law of conservation of mass says that I need to balance my equations. So the number of atoms on my reactant side must be equal to the number of atoms on my product side. They must be the same number and the same kind. So let's look at this example. So here I have H2O2 yields water. So I have 2 hydrogens over here, and I have 2 hydrogens over here. But what about this one oxygen? There's still an oxygen there's 2 oxygens over here and only 1. So where's this oxygen right here going to go? So this is not a balanced equation because where's the hydrogen or where's the oxygen? It's not accounted for. So again, we need to add the coefficients so that we can properly express our chemical reaction. So again, let's look at what we had. Whoops, sorry. Well, a little crazy here. So let's look at what we had. I have a total of 4 hydrogen here, a total of 2 oxygen here. So a total of 4 atoms, 2 hydrogen, 1 oxygen, so a total of 3. Not balanced. So what can I do? I can add coefficients in front. I don't want to change the subscript. If I change the subscript, I'm changing the substance that I have. It's something new. It's a new substance. So I have to keep these the same. Don't change it. So let's look at how we do this. So remember, product side, this is what we had. Reactant side, this is what we had. So hydrogens are balanced, but our oxygens are not, and our total number are not. So we have to fix that. So how can we do this? Well, notice right here, excuse me, my hydrogen said it was balanced, but my oxygen is not. So I have 2 oxygen right here. So I need to have 2 oxygens over here. So what can I do? I can add a 2 in front of my water, in front of my H2O. So what does that do? Well, then I will have hydrogens 2. What happened to my hydrogens? I now have 2 times 2, that's 4. So now my hydrogen's not balanced. So in balancing my oxygen, my hydrogen became unbalanced and my total numbers are not right. So we're not finished. I got to keep going. So what can I do? Well, remember, oxygens are okay, but how many hydrogen do I have over here? I have 4. So what can I do to make 4 hydrogen over here? I can put a 2, because 2 times 2 equals 4 hydrogens. So this allows me to have 4 hydrogens in front, or total, in the reactant side. So now let's look. I have 2 times 2 equals 4. That's good. Over here, 2 times 2, that equals 4. Check. Oxygen, 2, 2, 2, 2. That's good. So let's look at my total. So I have 4 and 2, that's 6. Okay, 4 and 2, that's 6. So notice my reaction is now balanced. So let's try another one. Let's try another one. Let's look at this visually, how this would look. So here I have my 2, notice 2H2 plus 1O2 yields 2H2O. Notice I have 1, 2, 3, 4 hydrogens. 1, 2, 3, 4 hydrogens. How many oxygens? 1, 2, 1, 2. Total of 6. Total of 6. Thumbs up. It's all set. So here are some practices that I want you to do and try out for yourself and see how you do. Okay, if you have any questions or need help with these, please make sure you reach out to me. Otherwise, bye guys. Have a good day.